All right, let's continue talking about multiplying polynomials. And then this section, we're going to go through some special products. So these are going to be really similar to what we saw last time. Some of them just have some kind of shortcut methods, which I don't actually use that much. If you like them, you can go ahead and use those. But I'm going to show you some formulas here in a second once we go through and take a look at what we do when we square binomials. So that's the first part of the section. So we have two kinds of special products. We have squaring binomials, and then we're also going to see something we saw last time where we have the sum and the difference of two terms. But let's start with squaring binomials first. So squaring a binomial means we have something that looks like this, m plus 3 squared. So now this is something we saw before back in the beginning of chapter 5 when we were talking about our exponent rules. So if you remember, if we had something like 3m in parentheses squared, we can distribute this exponent in. This does not work for this kind of thing where you have addition or subtraction in between. That's only for products. If we have addition or subtraction, we need to remember what it means to square something. So remember, squaring something means we're multiplying it by itself. So what I like to do, and there's going to be a shortcut in a second if you want to kind of remember the formula, but I like just thinking about what this actually means. So squaring something means we're multiplying it by itself. So we're going to take m plus 3 and multiply it by itself. And now it's something that we've seen before. We saw this in the last section. We can go ahead and FOIL this out. So first, m times m is m squared. Outside, m times 3 is 3m, so plus 3m. Inside, 3 times m is 3m again. So that's one thing we'll see when we're squaring is these two terms here are always going to match. And last, 3 times 3 is 9. And then let's combine our like terms. So 3m plus 3m is 6m. So m squared plus 6m plus 9. So just so you have that, remember to square means multiply by itself. And if you remember that, these ones shouldn't be a problem. Just remember that you can't distribute that square in there. Otherwise, you would completely miss out the 6m in the middle. We would have m squared, we would have the 9, but we wouldn't have the 6m. What you can use is the shortcut. And I put that in quotations because you still have to memorize the formula and plug things in. And I think plugging things in gets a little kind of weird at times. But the shortcuts for these, if we have addition in between, so let's say we have x plus y squared. What we're going to do is we're going to square the first term. And if you notice, we squared m to get to this. So we squared m. So we have x squared. And then if you noticed, we had 3m twice. So that's what we get if we multiply our first and our second terms in those parentheses, and then we double it. So we're going to add 2xy. And then our last term is going to be our last term squared, so plus y squared. So the only kind of tricky part here is remembering the 2xy in the middle. So if you want to use this, I'll use the shortcut on one of the ones down below. I'll do it on one of the ones with a minus in between. Because with a minus, the only difference is our first term is still going to be x squared. We're still going to have a 2xy, but it's going to be a minus 2xy. And then a plus y squared, because when you square something, it's always positive. Okay, so let's go ahead and take a look at some examples. And I'll just do one with the shortcut, and then we'll go ahead and do the rest just by squaring them, so multiplying it out. So let's go ahead and try 2m minus p squared. So for this one, let's go ahead and use the shortcut. So what we're gonna do is, you notice x here is our first term, so we're gonna square it. So we're gonna have 2m squared, and then minus 2 times x, which is 2m, times y, which is p, and notice how it's just the p without the minus sign. That's in between, the y is just the individual terms here. And then plus y, which is p squared. So now if we go ahead and start simplifying this, 2m squared, remember you have to square both of these, so 2 squared is 4, m squared is just m squared, minus 2 times 2 is 4, and then we have an m and a p, so 4mp, and then plus p squared. And there shouldn't be any like terms to combine when you're using the shortcut, so we'll go ahead and just leave that there. So again, if you like that, go ahead and use it. If not, just remember that squaring means multiply by itself. So let's go ahead and try some other examples here. Number 2, 4p plus 3q squared. So I'm going to do this one the other way. So if we square this, this means we're taking 4p plus 3q and multiplying it by itself. Just so you have it, this way is the shortcut. This is the FOIL method. So let's go ahead and start foiling. So first terms, 4p times 4p is 16p squared. The outside, 4p times 3q is 4 times 3 is positive 12, and then pq. The inside is going to be exactly the same, so another plus 12pq. Again, you can put qp if you want. Generally, we'll put it in alphabetical order. So I'll leave it as this. And then our last terms, 3q times 3q is 9q squared. And then if I go ahead and just combine those two terms together, we have 16p squared plus 24pq plus 9q squared. So again, whichever method you like better, I would just kind of pick it, stick with it, make sure you get some practice in. That way you're not trying to go back and forth and kind of confusing yourself with which one to use. All right, let's go ahead and try just a couple more of these. So number 3, let's do 3k minus 1/2 squared. And let's actually make this a plus. And I'll go back to using the shortcut method here so you can see it with another one. So shortcut here, it's addition. So we're going to have our first term squared, so 3k squared. And if you want to just square that straight away, you can. I'm just doing the individual steps here. Plus, so the next part is 2xy, so 2 times the first term, which is 3k, times the second term, which is 1/2, plus the last term squared, so 1/2 squared. All right, so if we square 3k, remember distribute, so we get 9k squared. With multiplication, we can multiply it in a different order. And that's actually a nicer thing to do here, because if we have 2 times a half, 1/2 of 2 is just 1. So then we have 1 times 3k, which is 3k. And then 1/2 squared, we can square the top, square the bottom, so we get 1/4. All right, and let's go ahead and do one more of these. X times 2x plus 7 squared. And this one I'll use the FOIL method. So with this one, if we were to use the shortcut, you have to square this first, because remember you do exponents before you multiply. So we can't distribute this in first, we have to square this, and then we'll distribute the x to whatever we get. So I'm gonna use the FOIL method. Either way works perfectly fine. If we use the FOIL method here, we still can't just distribute this x into here. What we have to do is write it out first. So I'll leave the x, and then we're gonna have 2x plus 7 times 2x plus 7. And then I'm gonna go ahead and distribute first. So we can distribute this x, and notice how it only goes into one of those 2x plus 7s, just the one right next to it. If we would have distributed it here, it would have gone in twice because we're squaring that. So that's why we can't distribute that there. So I'll go ahead and distribute this, leave this in parentheses because we're still gonna FOIL. So 2x times x, remember add the exponents. So we get 2x squared plus x times 7 is 7x. And then we still have another 2x plus 7 to multiply that by. Now let's go ahead and FOIL. So 2x times 2x is 4x cubed. 2x squared times 7 is a positive 14x squared. 7x times 2x, 7 times 2 is 14. X times x is x squared. So notice how we still get those matching inside terms. Even though our 2 binomials didn't match here, we had matching ones in the beginning. And then finally, 7x times 7 is 49x. So the last step here, just combine those inside terms and we get 4x cubed plus 28x squared plus 49x. So if you wanted to go through and do this with the shortcut, I'd recommend doing that if you like the shortcut. That way you can see if you have it down, and then you can check your answer with this one. If you're going through and doing that and you can't figure out why you're getting something wrong, you can just send me a picture of it and I can help you guys out with that. All right, let's look at our other shortcut special product. This one I do really like the shortcut for. So this one is for the product of the sum and difference of 2 terms. So what this means is if we have 2 binomials being multiplied, so x plus y times x minus y, you don't have to write down this middle part here. This is going to be why our shortcut works. But if you remember, when we FOIL this out, x times x is x squared. Our outside terms, x times negative y is negative xy. The inside terms give us x times y, positive. And then our last terms, positive y times negative y is a negative y squared. And so anytime we have these same terms, opposite signs, these inside terms always cancel. And so all we are left with is x squared minus y squared. So that's the first terms multiplied and the last terms multiplied. So we only need to multiply the first and the last terms. And one more thing here, these are called, and we'll see this a little bit more later, these are called conjugates. And you'll see this a lot more if you go into 96. Okay, let's go ahead and run through some examples here. And these are going to be pretty fast because this shortcut is really nice. So number 1, we're given y plus 3 times y minus 3. So in order to use this shortcut, you first want to check, do we have the same terms? Make sure they're in the same order. So it has to be the y first and then the 3, and then opposite signs in the middle, not opposite signs anywhere else. It has to be in between the two terms. If we do, then all we need to multiply are the first and the last. So y times y is y squared. 3 times -3 is -9. And that's all we have to do for these. So this shortcut's really nice. So let's go ahead and try some others. This one we have 8 minus x times 8 plus x. For this one, even though the x's don't go first, we still have 8's in the same place. So our 8's are first and our x's are second, and we have a minus and a plus. It doesn't matter if it's a plus and then a minus or a minus and a plus, as long as you have one of each. We can go ahead and multiply the first and the last. 8 times 8 is 64. Negative x times x is negative x squared. So you should always end up with that minus sign in between. All right, let's go ahead and try another one. Let's go ahead and do 10m plus 7 times 10m minus 7. So again, we have the same terms, opposite signs. So let's multiply the first and the last. 10m times 10m is 100m squared. 7 times -7 is -49. One other important thing to note here, because this is something we'll see in chapter 6 when we start factoring, we're going to be starting with something like this and be going backwards. If you notice, both of these terms are what we call perfect squares. So 100 comes from 10 squared, 49 comes from 7 squared, and m squared comes from squaring m. So that's another thing to keep in mind. Just kind of be familiar with it. You're not going to use it quite yet, but we will see that in chapter 6. Okay, let's try this one. 3r plus 1/2 times 3r minus 1/2. So again, same terms. We have 3r, 3r, 1/2, 1/2, opposite signs. Now let's multiply the first and the last. If you forget the shortcut for this one, or if you're unsure if you can use a shortcut, the best thing to always do is just completely FOIL it out. You'll notice that the outside and the inside terms cancel. So when in doubt, just FOIL. Doesn't matter if you use the shortcut or not, it's just going to save you a little bit of time. Okay, so 3r times 3r is 9r squared. Positive 1/2 times negative 1/2. You can always multiply off to the side if you want to, but we get -1/4. You're also just squaring each of these numbers. So square the top and the bottoms of each of those. And let's go ahead and try one more. Negative, parenthesis, t squared minus q times t squared plus q. All right, so this is one where You can do it how we've done it before. So this negative out in front is just a -1. You can distribute this in, but if you notice right now, this is set up really nicely that these two are conjugates, same terms, opposite signs. So we can use our shortcut. If we were to distribute this in first, we wouldn't be able to use the shortcut because we wouldn't have the same terms, opposite signs anymore. So let's go ahead and use our shortcut first, and this negative is just going to hang out in the front, but it still needs to have a parenthesis next to it because we still need to distribute that through. So if we use the shortcut here, t squared times t squared, t to the 4th, negative q times positive q is a negative q squared. And then we want to just distribute this negative in, which just changes the signs. So we get negative t to the 4th. Negative times a negative is a positive q squared. Okay, so we distributed after on that one just so we were able to use the shortcut. You could have distributed first and then just FOILed it out like just a regular polynomial multiplication problem. It's completely up to you what order you do it in. All right, so that's it for polynomial multiplication. After this, we're going to get into dividing polynomials, and this starts to get a little tricky. Dividing with a monomial is the first one we'll see. This one's a little bit easier. And then when we get to polynomial by polynomial division, that's where we'll see the long division. So if you need to kind of brush up on long division, which is regular numbers, I would definitely recommend doing that.